The time is now 5 p.m. We will get started with today's public information meeting regarding Phase 2 of the New Haven Line Power Program. Your rights through Title VI. No person shall, on the basis of race, color, or national origin, be excluded from participation or subject to discrimination in the development of this project. Voluntary post-meeting survey can be found at portal.ct.gov/CT DOT survey or following the QR code on the screen. Title VI information can also be found at portal.ct.gov/DOT/opportunity-and-business-development/title-VI. A recording of this presentation will be posted to Connecticut DOT's YouTube channel after the event. Closed captioning, including non-English translation options, are available on Zoom and YouTube. More information regarding Title VI can be seen on the flyer on your screen. Individuals and organizations may file a complaint by completing the Title VI complaint form found at portal.ct.gov/DOT/equity/title-VI. Complaints should be signed and include contact information and should be sent to the Office of Civil Rights, Federal Railroad Administration, 1200 New Jersey Avenue, SE, ROA-10, Mail Stop 5, Washington, D.C. 20590. More information about Title VI in Spanish can be seen on your screen. I'll leave this up for a few seconds.
Kevin, could you share your screen, please?
Is it not being shared?
I see Kevin's screen for the Title VI.
Okay, thank you.
How to view captions and subtitles in Zoom. First, click Show Captions, then click the speaking language. Finally, select the language you would like from the list shown. Closed captioning, including non-English translation options, are available on YouTube after the event. How to use Zoom Q&A. First, select the Q&A tool at the bottom of the Zoom webinar window. Then the Q&A window will open as seen on the right. Finally, please type your question in the text box and click Enter. If you are an audio-only participant, dial *9 to raise and lower your hand. Questions can be submitted by email to nazana.weeks@ct.gov. That's nazana.weeks@ct.gov. By phone at 860-594-2020. Through the Q&A toolbox during today's information session. Project webpage can be found at portal.ct.gov/DOT/programs/NHL-Power-/phase-2. The comment period is open through March 11th, 2026. In your correspondence, please be ensured to include the state project number 0301-0551. I'll now hand it off to Yuri to do some project team introductions.
Thank you, Kevin. So good evening. My name is Yuri Kulgis. I am an assistant rail administrator for the Connecticut DOT Office of Rail. Thank you for joining us. Richard Jankovic, our rail administrator, couldn't join us today, but I will pass it to Nabil next for introductions. Thank you.
Good afternoon. My name is Nabil Chaudhry. I'm the Connecticut DOT project engineer on this project. I'll pass it along to Nazana.
Good afternoon, everyone. My name is Nazana Weeks. I'm a Connecticut DOT project manager for the project. I'll pass over to Ashish.
Thank you, Nazana. Good evening, everyone. Welcome to the virtual public information meeting for the replacement of balancing substation at Sasko Creek and East Portchester. My name is Ashish Patel. I'm a project manager and a Traction Power lead design engineer for this project. For this project, we have our sub-consultant, VN Engineering, who is performing the public information relation scope of work. GM2 will be our civil designer. Savinsky Sullivan is our architectural scope of work designer. And Jacob will be performing the catenary design work. At this point, I'll passing along to David McKay, who will introduce himself.
Good evening. My name is David McKay with Guard Consulting Engineers. I'm the design delivery manager and project coordinator helping Ashish with this project. Also with us tonight is Eugene Chuang.
Thanks, David. My name is Eugene Chuang. I'm the CEO and principal in charge for Guard Consulting. And Kevin.
you, Eugene. I'm Kevin Ortiz. I'm with VN Engineers, and I'll be doing the engagement portion of this project. For today's meeting agenda, we'll start off with the project overview, then followed by the Sasko Creek Balancing Substation and East Portchester Balancing Substation overview, where we'll discuss the site design and impacts. And we'll finish off today's information session with a Q&A session. I'll now pass it on to Ashish to talk about the project overview.
Thank you, Kevin. Hello again, everyone. First, I would like to give a brief overview of the type of power system on a New Haven main line. There are two types of power system on a New Haven main line. One is called the signal power system, and a second is called the traction power system. The main focus of this scope is for the traction power substation. The movement of the railroad traffic is controlled by the signal system. The actual train are propelled by the traction power on a New Haven main line. This slide represents the traction power system on a New Haven main line. There are few utility supply substations located on a New Haven main line. On this slide, the utility transmission tower shown on a bottom slide represent the utility power is being delivered from utility supply substation to the railroad traction power substation. The train is shown receiving traction power from aerial catenary wires. The major scope of work for this project is to replace a total of 2 antiquated traction power balancing substations on a New Haven main line. Now I'll give a brief overview of the project scope of work. There are many project stakeholders for this project. Connecticut DOT is the owner, Metro North Railroad is an operator, and the end user, Federal Railroad Administration, also called FRA, is a project fund provider, Town of Westport, Town of Greenwich, Eversource, FM Global, Department of Energy and Environmental Protections are the major project stakeholders. As a part of this project, a total of 2 existing traction power substations are going to be replaced with the new state-of-the-art technology on a New Haven main line. The first site is located at Sasko Creek, Town of Westport, and the second site is located at East Portchester, Town of Greenwich. The balancing substations are also called traction power substation. The traction power substation supply power to the railroad on a New Haven main line using the aerial railroad feeder. We'll be referring to Sasko Creek as a Site 1 and East Portchester as a Site 2. The existing Sasko Creek balancing substation receive utility power from Eversource and supply traction power on a New Haven main line between Cascade and Devon. The existing East Portchester balancing substation acts as a voltage balancing substation and does not receive utility power from local utility company. Both balancing substations were originally constructed in the 1980s. They are about 45 years old. The normal lifespan of these railroad equipments are about 30 years. So these substations are well over their normal lifespan. The existing balancing substation equipments are outdated and it is difficult to replace the parts. So it is very difficult to keep in running operating condition. So it affects the railroad reliability and the train service. I'll give a brief overview of the replacement of Site 1 Sasko Creek Balancing Power Substation scope of work. The existing Sasko Creek Balancing Substation is at Sasko Creek off of Clayton Street in the town of Westport, Connecticut. As we can see on this Google image, the New Haven main line 4 tracks are shown on the north. The existing Eversource outdoor rated supply substation is shown on the east, and existing Sasko Creek balancing substation is located south side of track 4, adjacent to the Clayton Street. The project site entrance is also from the Clayton Street. A portion of driveway is shared by residents of Westport, Eversource personnel, railroad personnel, town of Westport personnel. So it is very critical that we respect each other during the construction phase. I would like to point out the closest residential houses are approximately 130 feet away from the project site. This picture shows the existing outdoor rated switchyard type balancing substation at Sasko Creek. The main utility power comes as a medium voltage from Eversource. There are total 2 aerial utility power feeder comes from Eversource supply substation to the existing Sasko Creek switchyard balancing substation. The existing Sasko Creek transformer step down medium voltage coming from utility company and feeds power, traction power to the New Haven main line using the railroad aerial wires. One set of feeder feeds traction power from Sasko Creek all the way to Cascade, Connecticut, and a second set of aerial wire feeds power from Sasko Creek up to east to the Devon, Connecticut. The existing equipments are outdated and struggle with the reliability. Recently, the train traffic also increased on a main line. So any failure in the existing balancing substation could result in a shutdown of entire Northeast corridor. Meantime, Eversource started replacing some of their existing electrical apparatuses in the supply substation. It will strengthen incoming utility power system. Once a new substation being energized, the existing traction power substation switchyard will be demolished and removed from the switchyard. Next, I'll be discussing the common design and construction step involved from designing the balancing substation from start to finish. We will see the actual site location in a moment. The proposed site location is critical for construction of balancing substation. Connecticut DOT and Metro North adopted implementing the designing of arc resistance switchgear under medium voltage application. We have been designing prefabricated walking type arc resistance substation for balancing substation, supply substation, and the signal substation under New Haven main line power program. The newer substations are unmanned and all circuit breakers are controlled from remote location. In this case, remote location is considered as a ground center terminal. The SCADA system, also called the supervisory control and a data acquisition system, will be designed for controlling and monitoring balancing substation from remote location. The digital protective relays are state-of-the-art, reliable, easy to program, easy to maintain, will be designed under this project. The 125-volt DC station power will be designed and battery system will be used under this balancing substation. The outdoor rated type auto transformer will be designed to balance the traction power voltage system. The cable walls will be designed under the medium voltage enclosure. The working platform will be designed for maintenance of HVAC units mounted on an enclosure, balancing substation enclosure. The ground grid will be designed to mitigate the step and touch potential. The cross-track feeder will be designed to carry the disconnect switches and an aerial wire running on the New Haven main line. This slide shows the proposed location of the Sasko Creek balancing substation. I understand this drawing shows the lots of lines, but I'll try my best to explain it, this layout. The red color block represents the proposed location of balancing substation. The proposed site is chosen adjacent to the existing site for various operational reasons. The chosen site is adjacent to track 4 and adjacent to Eversource supply substation. The entire site is owned by state of Connecticut. The installation of proposed balancing substation building requires flat ground. The proposed site has an elevated ground. The new balancing substation foundation will be designed as a retaining wall to compensate for the existing ground elevation difference. The new walking type wall will be constructed for placing the new balancing substation enclosure and pulling cable in and out. The balancing substation will be constructed as a prefabricated walking type metal enclosed building. It will house various traction power equipment. The light green color block represents the proposed location of auto transformer. The new auto transformer yard will be designed on the west side of the balancing substation. The new retaining wall will be designed to support a total of 2 new auto transformers. The retaining wall will also serve as a fall protection, and it will have a 8 feet high chain link fence on the top. The southeast side yellow color represents the new asphalt driveway over the existing gravel driveway. An 18-inch corrugated metal ply will be replaced under this driveway. A total of 4 new catenary structures will be constructed to support the new disconnect switches and aerial wire on the New Haven main line. The supply structure will be constructed to support incoming aerial wires adjacent to the Eversource utility supply substation. Light gray color represent the underground concrete encased duct bank. The incoming and outgoing cable will be constructed under this underground utility duct bank. The supply duct bank will be constructed under the existing gravel driveway to the new incoming supply structure. A portion of this gravel driveway will be closed during the construction of the underground concrete encased duct bank. One of the underground concrete encased duct bank will be constructed adjacent to the Clayton Street and crossing the Maple Avenue towards the west side of the Maple Lane Bridge. This slide shows the elevation view of the new walking type balancing substation. It is also called as a prefabricated balancing substation enclosure. It will be installed on the top of the full walking type wall. The fabrication of entire substation enclosure will take place at the balancing substation manufacturer factory. After successful testing at the factory, the balancing substation will be delivered at the project site. The contractor will be using the crane to unload the substation from delivery truck to the substation foundation. This picture shows a similar walking type prefabricated balancing substation enclosure being installed adjacent to the New Haven main line at the Bridgeport, Connecticut. As we can see, this is a typical railroad equipment being installed adjacent to the New Haven main line railroad right-of-way. The recent construction technology is moving away from building a brick and mortar building, which will require a lot more labor work at the job site. Balancing substation manufacturer would have to send each pieces of equipment right to the job site, and it will create the delay into the project construction. So the overall cost would increase. So this is the reason the balancing substation would be much easier to fabricate into the balancing substation manufacturer factory. Next, I'll briefly discuss the potential construction impact at Sasko Creek. As discussed earlier, one of the underground concrete encased duct bank construction will take place adjacent to the existing gravel driveway by the Eversource supply substation, and another underground concrete encased duct bank will be constructed adjacent to the Clayton Street and across Maple Lane. So vehicular traffic may be impacted on a Clayton Street and a Maple Lane. The approximate construction duration is about 4 weeks for completing the underground concrete encased duct bank. The proper maintenance and protection of traffic signage will be provided prior to construction start of this underground concrete encased duct bank. The vehicular traffic will be guided by traffic police. The temporary H20 rated steel plate will be used to cover the open portion of the underground concrete encased duct bank during the concrete curing process. It will allow vehicular traffic flow during the night time. The existing sewer, water, and electricity on a Clayton Street and a Maple Lane will not be affected by this project. The noise pollution will be minimum because the majority construction will take place during the daytime, except the catenary structure installation work and a final substation cutover will take place during the nighttime due to railroad operational impact. The balancing substation will be delivered to the project site after successful testing at the factory. The pedestrian traffic and vehicular traffic will be guided by the police. I will discuss detailed substation delivery method in a moment. This slide shows the maintenance and protection of traffic signage will be installed on a Clayton Street prior to starting underground concrete encased duct bank construction adjacent to the Clayton Street. The work zone will set up daily basis as section by section construction method. This slide shows the maintenance and protection of traffic signage will be installed on the Clayton Street and the Maple Lane prior to starting the underground concrete encased duct bank construction adjacent to Maple Lane. The work zone will set up again daily basis as section by section construction method. The traffic police will be utilized at this location and the vehicular traffic will be guided by the traffic police. Only one lane will be open for vehicular traffic during construction of underground concrete encased duct bank crosses the Maple Lane. As discussed earlier, the balancing substation will be delivered to the project site after successful testing at the manufacturer factory. Crane will be set up on the state property adjacent to the proposed balancing substation foundation. The pedestrian traffic and the vehicular traffic will be guided by traffic police. This picture was taken from one of the past projects. The crane is lifting the substation enclosure from the delivery truck and placing on the top of the substation foundation. This slide shows the substation enclosure and auto transformer delivery truck route starting from I-95 North or I-95 South, depending on the trucking company's choice to propose site location. The contractor will be using the crane to unload substation enclosure from delivery truck to the substation vault foundation, as well as the auto transformer from delivery truck to the auto transformer foundation. Substation delivery, auto transformer delivery, and unloading process may take approximately 4 hours from start to finish. The main goal is to deliver balancing substation at the project site without any kind of impact or incident. The proposed work plan will be submitted way prior to delivery date being scheduled. I will give a brief overview of the replacement of Site 2 East Portchester balancing substation scope of work. The existing East Portchester balancing substation is located at East Portchester, adjacent to Henry Street in the town of Greenwich, Connecticut. As we can see on this Google image, the New Haven main line 4 tracks are shown on the north. The existing East Portchester balancing substation is located south side of Railroad Track 4 and end of Henry Street. The project site entrance is from the Henry Street, located on the south side of New Haven main line. The portion of driveway is shared by residents of Greenwich and the railroad personnel. So again, it is critical to respect each other during the construction phase. There are many residential houses, apartments, and a commercial building are located adjacent to the proposed site. This picture was taken at the end of Henry Street on the south side of New Haven main line. It shows the existing balancing substation brick and mortar building. On the right side is act as a control house. Railroad training building is shown on the left side of the picture. The existing balancing substation is again outdoor ready switchyard type balancing substation. This substation does not receive utility power. It acts as a voltage balancing substation. So one set of railroad aerial traction power wire are tied to the east of the balancing substation, and another sets of railroad aerial traction power wires are tied on the west side of the balancing substation. As discussed earlier, the existing equipments are outdated and struggle with the reliability. So any failure in the existing balancing substation could shut down the entire northeast corridor train traffic. Once the new substation being energized, the existing traction power equipment will be demolished and removed from the existing switchyard. The proposed design construction steps for the East Portchester balancing substations are similar as we discussed under the Sasko Creek balancing substation. However, this site does not have optimum available property adjacent to the existing balancing substation. The state of Connecticut is in the process of acquiring additional needed property from adjacent property owner. The temporary easement is also needed for delivering balancing substation and placing crane into the adjacent property owner. This slide shows the proposed site layout. The red color block represents the proposed location of balancing substation. The proposed site is chosen adjacent to the existing site for various operational reasons. The chosen site is adjacent to track 4. The entire site is not owned by state of Connecticut. The installation of proposed balancing substation building require dry ground surface. The proposed site has some water ponding issue. The new site drainage system will be designed under the initial construction stage. The installation of proposed balancing substation building require an elevated substation foundation to keep away any kind of water coming inside the cable vault. The new walking type vault will be constructed for placing new balancing substation enclosure and pulling cable in and out. The new balancing substation will be constructed as a prefabricated walking type metal enclosed building. It will house various traction power equipment. The blue color block represents the proposed location of auto transformer. The new auto transformer yard will be designed on the west side of the balancing substation. The new 8 feet high chain link fence will be designed to deter anyone coming into the auto transformer yard. A total of 2 new catenary structures will be constructed to support the disconnect switches and a new aerial wire on the New Haven main line. Light gray color line represent the underground concrete encased duct bank. The incoming and outgoing cable will be constructed under this underground concrete encased duct bank. The new bituminous concrete pavement will be installed at the end of Henry Street. This slide shows the elevation view of the new walking type prefabricated walking substation enclosure being installed on the top of the new vault. As discussed under Sasko Creek, the fabrication of the entire balancing substation will take place at the manufacturer factory. After successful testing at the factory, balancing substation will be delivered at the project site. Contractor will be using the crane to unload the substation from delivery truck right to the top of the foundation. I'll briefly discuss the potential construction impact at East Portchester. As discussed earlier, the state of Connecticut is in the process of acquiring property from adjacent property owner for construction of the balancing substation. State of Connecticut is also in the process of acquiring temporary easement from adjacent property owner for placing the crane and delivering and unloading of the substation from delivery truck. The construction of new drainage system will impact site accessibility by the railroad personnel. The construction staging plan will be developed to mitigate any site accessibility during the construction of drainage system. The existing sewer, water, and electricity on the Henry Street will not be impacted by this project. Noise pollution will be minimum. As discussed earlier, the majority construction will take place during the daytime, except the final cutover and installation of the catenary structure due to railroad impact, operational impact. The balancing substation will be delivered to the project site after successful testing at the factory, and traffic police will be utilized to guide the vehicular traffic during the delivery of the substation. I'll discuss detailed substation delivery method in a moment. As seen earlier, the balancing substation will be delivered to the project site after successful testing at the factory. As shown in this picture, the crane will be utilized to unload the substation enclosure from delivery truck right to the top of the foundation, and the traffic police will be utilized to guide any kind of vehicular traffic during delivery of the substation. As discussed earlier, this project was taken from one of the previous substation project on the New Haven main line. This slide shows the substation enclosure and auto transformer delivery truck route from the I-95 north or south, depending on a substation, a trucking company's choice to the proposed site. The contractor will be using the crane to unload the substation and auto transformer to the proposed site location. The entire process will take about 4 hours from start to finish. Again, the main goal of this MPT plan to not to have any issue during the delivery of the substation and auto transformer. The proper work plan will be submitted way in advance, so everyone will have a chance to review it, make a comment, and approve the plan way prior to the substation delivery date is being scheduled. I'll give a brief overview of construction schedule. This slide shows the overall project construction schedule from start to finish. The final design will be completed by September 2026. The contractor will sign the contract with State of Connecticut, and the state will give notice to proceed to the contractor in early May 2027. The actual construction will begin at the end of May 2027. Both sites will be constructed simultaneously. There are some long lead items as discussed earlier, the prefabricated walking type substation enclosure and auto transformer. So the tentative date for the final construction completion is in February 2031. Thank you very much for your support this evening. I'll pass this presentation to Mr. Ortiz.
Thank you, Ashish. Again, reminder for questions, they can be sent through email to nazana.weeks@ct.gov. That's nazana.weeks@ct.gov. By phone at 860-594-2020. You can still submit your questions using the Q&A toolbox. And more information regarding the project can be found at portal.ct.gov/dot/programs/NHL-power/phase-2. Comment period is open through March 11, 2026. Please be ensured to include the state project number 0301-0551 in all your correspondence. We'll now go through questions submitted in the order they were received. I don't see any questions that came in during the presentation. Again, if you would like to leave a question, you can use the Q&A toolbox at the bottom of your screen. You select it and a pop-up will appear and you can type your question right there.
Thank you, Kevin. And just to reiterate, the comment period is open through March 11. So with that, I think we can close the meeting. We'd have it Nazana. Nazana, if you want to do the closing remarks before we adjourn the meeting, please. And then we can pass it to Kevin. But thank you, Nazana.
Sure. Thank you again, everyone, for attending this afternoon's public information meeting for this project, Phase 2 of the New Haven Line's Power Improvement Program. We appreciate your time, questions, and feedback. Once again, the comment period is open until March 11, so please feel free to submit your questions or comments via email or phone to us. Thank you again, everyone.